All right. Now, remember in our previous exercise, we total our lighting circuit and our socket arrangement circuit. But now, let me recap on this socket arrangement. Okay. Let me refer you to one other requirement. I treated this. Watch the previous exercise. You understand this more better. But let's do a recap. Now, ring circuit requirement is 30 amps or 32 amps for protective device. Then the total routing distance, the cable routing distance, the distance of the cable coverage is going to be confined within 100 meters only. Then cable size is going to be 2.5 mm square. Then number of socket point in that circuit is unlimited, but 10 point is recommended. Okay, that is why I put TP point, 10 point. Now for radial, this is also the requirement, either 32 amps or 30 amps. Then the length of cable is going to be 75. Cable size is this. Then total number of points within the circuit is unlimited, but 10 point is recommended. So that is this area. So let's go back. We're going to choose these two. One of the circuits is going to be ring. The rest of them are going to be radial, so that the cost of the installation will be reduced. Okay, now let's come there. Let's total before we decide distribution board. Let's recap on the DB again once more. This is the distribution board characteristics. Any of this distribution board you choose, these are their final breaker size, breaker quantity. The final number of breakers the distribution board is composed of is here. That's why I put them in bracket. All right, so before we choose which of the distribution board will be compatible to our calculation, let's let's have our total circuit. Now, for our final circuit for the lighting, we have 17. For the ring, we have 8. For the power, we have 42. For the water heater, we have 38. Then the total amount to 141. Okay, I know we have approximation, but I want to use this round figure. All right, because that approximation, the additional of 25% spare in the distribution board will take care of that approximation. So let's go. If we have this 141. So which of the distribution board we want to use? So let's go back here. Okay. All right. Oh, sorry. We have this. We have this to be, just get your calculator. This after approximation. What we have is 1. The total circuit was 113. Okay. If you total the whole of this circuit, 17 plus 8 plus 8 plus 42 plus 38, we are going to have 113 circuits. So we are going to add 25%, so that we make allowance for spare breakers in the distribution board. So what we are going to do is this. This is the total circuit. Let's add 25% to that. So we're going to say that multiplied by 1.25. Sorry. 113 multiplied by 1.25. Sorry. 100 and this multiplied by 1.25. We are having this. That is what we have here now. All right. So now, if we have this as our total circuit in the entire floor, so which this of the distribution board will go? So let's try this. Let's see this. Let's see D8, that is 24. Let's work with 24 way. So let's see if we are going to use D8 to divide the entire circuit. So get your calculator once again. We're going to have 141 as our circuit. Divide by 24. So we're going to have approximately 5 distribution board. Okay, this 5 distribution board is what we're going to need. Remember that 24 breakers. Okay, is for the D8. Now, if we have 24 breakers in each of the DB, how many breakers is going to be left unused, that is going to be spare? How do I go? So what you're going to do is this: get your 25%. If we have 25, if we have 24, we have 24, we're going to say divide by 100 times 25. It's going to be 6. So if we have 24 breakers, okay, you're going to be used only 18. You're going to use only 18 out of 24. So 6 breaker is going to be spare. So how are you going to do the 6 breaker that is spare? It's going to be, remember that our calculation for the lighting point is going to be, remember the calculation, let's just repeat the calculation for lighting circuit. We have, remember, we have 100 watts. We now multiply 100 watt by 13 number, 13 point. Further multiply by a factor of 1.8. This is what we got. We now divide by 230. We now got 10 amps. That is for protective device. Now remember that when we are providing 6 in our each of the distribution board, we're going to have a spare breaker of 6 pieces. So that spare breaker, lighting point is going to give a priority. So lighting point is going to have 2 breakers. Out of the 6, we're going to have 10 amps times 2. We're going to have 10 amps, two pieces of 10 amps left unused. That is for lighting circuit. Okay. Then for the ring circuit, we are going to have 30 amps spare. As for the air conditioner, with our calculation for air conditioner, we're going to also have 15 amps spare. Then for the water heater, based on our previous calculation for this breaker size, we also have 15 amps. So that is 5 in total. So which other one again? Perhaps let's just say this one is for lighting, this one is for ring, this is for AC, this for AC, maybe 15 again. Yes, so this is 6. This one, these 2 for lighting point, this one for ring. Okay, then this is for AC, this also for AC, and perhaps this is for water heater. Okay, just use your initiative, or we can also say 30 again for ring. We provide 2 for 30 for ring. So this is for lighting, this 2 is for ring circuit socket, then this is for AC, perhaps this is for water heater. Okay, so this is 6 spare that are going to be left unused in that distribution board. All right. Okay, so the next exercise we are going to discuss about how to now size our DB incomer and DB service cables and our central central switchboard, our busbar system, and determine our voltage drop for each of the DB, and now determine our generator sizing and our transformer sizing, and we will now start applying our diversity factor. Okay, we're going to apply our diversity factor and produce the appropriate table that I told you about. And we're going to produce different tables. This is one of the tables we're going to generate. Okay, all right, so we're going to do that. Then subsequently we do the rest of the calculation and the roundup, and also do our earthing system arrangement. Okay, all right, thank you. Endeavor to share and comment so that subsequent video will also prompt up to your own page. Okay, I prefer you share to students and practicing engineers and contractors and electrical business you have, or share to other groups that are associated to electrical studies. Okay, so that we share knowledge together. Thank you.